value of teaching engineers how to reason about programs in terms of how much energy they use is profoundly important. We built our own board that allows students to write software and to measure the implications, the power implications of that software. The project is called PowerDué. It's a derivative of the Aduino Dué. It has a processor that the students run their software on, but importantly, the rest of the board, filled with sensors and actuators and Wi-Fi and Bluetooth radios, has power metering built into it. That when you run your program, you can see how much power went to the Wi-Fi, into the Bluetooth, into the sensors. And in particular, if you wrote your program in a way that uses tasks or threads, we can allocate the power to each one of those threads individually. So if we think about the Internet of Things, whether you're thinking sensors in the environment or Fitbits, many, if not most, of these devices have to be subject to what we call the Ohio principle, which means only handle it once. So it becomes a first-order consideration in writing software to make sure that the software uses the hardware resources in a minimalistic way. It just sips power when it needs it. And there are some things that you can do in programming that are really dumb in terms of using energy, and there's some that are smart. PowerDué helps students understand what the smart things are to do in software. And the benefit, of course, is that when they do this, the battery lasts for 5 years instead of lasting for 5 minutes. In the Internet of Things, we want to be able to do sensing across devices. We want devices to be able to work in concert, so to speak. So when you listen to an orchestra playing, you'd very quickly be able to recognize somebody in the violin section who's playing a little late or a little early. It just wouldn't sound right. It would sound dissonant. We have a lab where we teach the students to take these PowerDués, which, by the way, have the ability to generate sound. We take all of these PowerDués from all the students and we line them all up together. They have to synchronize with one another, and we send them all MIDI data at the same time, and they have to play in synchrony. So the students who got the synchronization right will play their musical notes in concert with the others, and those that didn't, it's very obvious that they're playing late or they're playing early. The relevance of that is when these same students go out and write applications for the smart city, where they need to sense things in the environment, things in intersections with time synchronization. They know how to do it. They know how to create time synchronization between the individual sensors at low power, and they learned it by creating a MIDI orchestra.